So this is section 4.3, Properties of Logarithms. And what we're going to do here is we're going to expand our logarithms and we're going to condense our logarithms, okay? First we have a few properties that we need to learn about though. So the first one is the product rule. Okay, the product rule. So product means multiply. So the product rule is log base b of m times n equals log base b of m plus log base b of n. So multiplication equates to addition. And it's just like with exponentials. If you think back to if you had x to the fifth times x to the third, what did you do with those exponents when it was multiplication? You added them together. So that was x to the 5 plus 3. Okay, so I just wanted to point that out, that it's very similar. Multiplication equated to addition. Multiplication equates to addition. Okay, so let's say for a minute that we have log base 3 of 9x. That we would break up into log base 3 of 9 plus log base 3 of x. Okay, and then we would also need to simplify that if we can, because you know we can. Evaluate. So 3 to what power gives you 9? That's 2. So 2 plus log base 3 of x would be that expansion. Okay, so that's the first rule, product rule. Second rule. Next we have the quotient rule. The quotient rule says log base b of m divided by n equals log base b of m minus log base b of n. So now division equates to subtraction. Okay, so for example, if you have log base 4 of x divided by 16, that would be log base 4 of x minus log base 4 of 16. You can evaluate this part. 4 squared is 16, so this is 2. So log base 4 of x minus 2 would be that expansion. Third rule. Is the power rule. The power rule says log base b of m to the p equals, all that happens is this p comes to the front and becomes the coefficient. So it's p times log base b of m. For example, log base 5 of 5 to the 8th. You would take the 8, bring it to the front. That gives you 8 log base 5 of 5. And anytime you have the same bases, that becomes 1. So we just get 8. All right, let's put a couple of these together. So these are some combined examples. So let's say that you have log base 3 of 27 over 5x. Log base 3 of 27 over 5x. So we're going to split this. First thing we're going to do is take care of the division. So this will be log base 3 of 27 minus log base 3 of 5x. Now we'll split the times right there. So we're going to keep the log base 3 of 27 minus, and then this is log base 3 of 5 plus log base 3 of x. Now be careful here, because this subtraction goes to this entire thing. So that means this subtraction goes to this entire thing. So you have to put it in parentheses, okay? And then we also need to simplify or evaluate where we can, so we can kind of kill two birds with one stone with this next move. 3 cubed is 27. So this right here is just going to be 3. And then we can distribute this minus into both of those if we want to. So that would be 3 minus log base 3 of 5 minus log base 3 of x. And there's log base 4 of x over 64 squared. So since this exponent of 2 is on this entire thing, it comes out to the very front. So now we have 2 times log base 4 of x over 64. Now we need to take care of this minus, or this division, and make that a minus. But remember, this 2 is being multiplied by the whole thing. So we need 2, and then when we break this up, log base 4 of x minus log base 4 of 64, that needs to go in parentheses or brackets, some sort of grouping symbols. And then we can evaluate this one. 4 to the third power is 64, so our final expansion will be 2 bracket log base 4 of x minus 3. Let's go the opposite direction. Let's go ahead and condense. Your directions will say, write as a single logarithm. Write as a single logarithm. So when you see that, that means take those expansions we just did and put them together as one. So we call this condensing. Condensing. So let's start simple. Let's say that you have 2 log of x plus 1/2 log of y. Whoops, that's not a base. Log of y. So this is the common log because there's no log actually written in. So what's actually happening is the base is understood to be a 10. Okay? But it wasn't initially written, so we're not going to write it in. We're just going to try to get used to knowing that if it's not written there, it's understood to be 10. So the first thing we do is, since this 2 is only the coefficient for the log of x, we're going to take the 2 and attach it as an exponent of x. Same thing with the 1/2, attach it as an exponent of the y. So this is log of x squared plus log of y to the 1/2. And then, since this is plus, that becomes multiplication. So we're going to put those together to be log of x squared y to the 1/2. And I just like how it looks if you put that in parentheses. It just kind of finishes it off and lets you know exactly what you're taking the log of. Okay. Let's do one more. And we're also writing this one as a single logarithm. So we'll do 2, grouping symbol, natural log of 3 plus natural log of x minus natural log of 8. So just like with everything else, whenever you have grouping symbols, you do what's inside the grouping symbols first. So we have to do all of this, and then we can deal with this too. Okay? So when you're putting them together, you want to make sure that you deal with the plus first and the minus second. If you deal with the pluses first, that puts you into your numerator and your denominator. Okay? So what we'll have now is 2 bracket natural log of 3x minus natural log of 8. And so now we should be able to tell that this 3x is going to be in our numerator and this 8 is going to be in our denominator. Okay, so we'll put those together. 2 natural log of 3x divided by 8. And now that we have it down to 1 natural log, we can take our 2 from the front and use the power rule to put it on the exponent. So this will be natural log of 3x over 8 squared. Be careful with how you write this. You do have to have parentheses here. Think about it this way. If you were to have 3x squared over 8 like that, what's the squared actually on? It's only on the x if you look at it this way. Okay, where here it's on the entire expression of 3x divided by 8. Okay, and so that is expanding and condensing logarithmic functions. Now try your home practice, please.